Okay, this is 8.2 in the textbooks. Solve problems involving composite shapes. A lot of it's on the board. It's a very simple lesson. Okay, we're taking a complex shape and we're actually making it into a smaller shape that we're familiar with. Okay, and then we just add up the areas. So the problem involves students are building a recreational area. They need to submit a plan. They need to give areas and they need to give perimeters. Okay. So one of the first areas that they're looking at is the volleyball courts. So we need to determine the area and the perimeter of these courts. So we know that the area formula for a rectangle is just length times width. So we take that length times width. We know its length is 18, width is 10. We multiply them together. So we have the area of one of the volleyball courts. Because there's 2, we need to multiply that by 2. That gives us 360. And again, the units are meters squared. Don't forget that. Perimeter is just meters, area is meters squared. The only issue we run into when we're dealing with perimeter is that we have this shared perimeter right here. So we can't just double the perimeter of each court because we don't need a perimeter material here. Okay, so this doesn't count towards the perimeter, so you need to subtract that. So in order to find that distance, we take one of the length, which is 18, and we minus the known value of 4.5 to give us this length here, which is 13.5, okay, which we need to find the total perimeter. Okay, once we have that, then we just add it up. 13.5 plus 10 plus 18 plus another 10 plus another 13.5, etc. We add them all up, we get a perimeter of 103 meters. Any questions there? Yeah?
Can't you just figure out the area, the perimeter multiplied by 2 and then subtract by 4.5?
Yes. Okay. Food court. We're looking at this area here. We divide it into 2 shapes. Okay, we don't have a formula for this shape itself, but we do have a formula for a trapezoid. So we divide it into 2 trapezoids. We know the formula for area of a trapezoid. If you don't know it, please get familiar with it. It's the bottom base plus the top base, or vice versa, multiplied by the total height divided by 2. Okay, so we have all those dimensions here. It's given to us, the height is 2.5. That's from this center line to there. It's also the height of the trapezoid. It would work the same way this way. The reason we know those two are the same is because all the other dimensions are equal. Okay, that's what these equal signs represent. This is 3.2, this is 3.2, 3.2, 3.2, 3 and 3. Okay, so we use the area of a trapezoid formula. We figure out that the area of the trapezoid is 12.5. So just follow this down here, 12.5. So the total area of the food court then is 2 trapezoids. 12.5 times 2 is 25. Any questions? All right, moving right along. We have the area of our family beach. So this is this odd shape here. Okay, we're going to take this shape. Perimeter is obviously the easier one. We just add up all the exterior pieces. Okay, so let's look at perimeter first. That's at the family beach. So we're just taking all of those side lengths, 11.8 plus 8 plus 2 times 9.2. So that's just this area. That's what we're looking at. This is the wading pool. We're looking at the perimeter of the family beach. So we're adding this, 2 of these, plus 11.8, and plus this, which is 8. Okay, that gives us 38.2. The area of the family beach. Again, we can consider it being a trapezoid. So we're going to use that same formula. Okay, one base plus the other divided by 2 times height. So we would consider this one side 8, this the other 11.8, and then divide it by this height, which again is given as 9. Okay, so all the information is given. We figure out our area is 89.1. Finally, we're looking at the wading pool. It's here. It looks like a strange shape, but it's just a kind of the merger of 3 rectangles. Right? So we can easily figure out that knowing the area for a rectangle is length times width. So we find the large rectangle, which you can envision goes all the way around. So we're taking this total dimension and timesing it by this total width. Okay, that gives us the large rectangle. And then we subtract each one of these little corners. Okay, it's given that the corners dimensions are 1 by 1, so we should subtract 4 of them. Okay, so 53 minus 4. There's probably about 10 different ways you could have found the area for that, right? You guys are familiar with that? We can divide it in different ways. We could have found the area of that rectangle, the area of that rectangle, and the area of that rectangle, and added them together. Okay, there's a bunch of different ways you could have done it. Okay, that's one way. Perimeter we went over. The total area, we're just going to add up all the areas, and the total perimeter, we're going to add up all the perimeters, making sure not to double any perimeters. Okay, if you do find the perimeter of two objects and they're touching each other, you can't add that perimeter where they actually have contact. Okay, because that's not part of the perimeter, right? It's now on the inside. So if I just found the perimeter of this shape and the perimeter of this shape and I added them up, my total perimeter would be wrong. Okay, I'm going to finish off very quickly the last example. It asks you to calculate the shaded area. Please don't pack up. 1 minute. 1 extra minute, so that we don't have the sound of packing up and you guys are paying attention. We know that this is 3 centimeters. This is the radius, okay? If that's 3 centimeters, we also know that that's 3 centimeters. If that's 3 centimeters, so is this, and so is this, and so is this. So the total distance then, here we can figure out the diameter of the large circle. Once we have the diameter of the large circle, we can divide that by 2 to get the radius. We know that the area of a circle formula is pi r squared. So we take that radius, which is 6, we plug it into the formula, we figure out the area of the large circle. Then we figure out the area of the small circle, times those by 2. So that gives us the total area of the 2 small circles. Subtract the large area, the 2 small circles from the large area, we'll get the area of the shaded region. Any questions on that? Very simple. Finally, in summary, this is the last part, might be a little bit tricky. To find the perimeter of a hexagon, you just add up the sides. To find the area now, this might be the only thing that might be a bit tricky. Okay? You're given this height from the center to the bottom. What you can do now is create a triangle. Okay? You create a triangle with a height of 1. So we know the formula for area of a triangle is 1/2 base times height. You figure out what the area of that one triangle is, and now you know, because all the sides are the same, you have 1, 2, 3, 4, 5, 6 triangles. Multiply that area by 6, and you have your area. Okay? That's it.
Could you also do like 2